Welcome. Today we're going to start to go through chapter 9 of the Plutus book, which details what the authors call a more ambitious and realistic example, namely a crowdsourcing campaign. Now, in such a campaign, the owner of the campaign sets a funding target, an end date, and a collection deadline. So the first thing we're going to do is we're going to define a type that has that information. Okay, call it campaign. Don't like that. That's better. So first we have a campaign owner. Which is a public key. Right, what I'm going to do, let's put it together. No. Then I have the funding target. Should be in header. End date. Slot and the collection deadline. Should also be slot. Okay, and this type will derive the following type class instances for the campaign. Show generic to JSON. JSON to schema. Yeah. Then, since we're going to be using this type of the blockchain, we will call make a lift and then campaign. There we go. Great stuff. Now, if the total, reading from the book, if the total of all contributions reaches the funding target, the owner has time to collect all contributions before the collection deadline. However, if the target has not been reached, or if the owner fails to collect the funds before the deadline, contributors can reclaim their contributions after the deadline. So in order to help us program all that, we're going to use a number of helper functions. We've got the first function is collection range. Yeah. Okay, so collection range. Takes a campaign, returns a slot range. This is a time interval. Slot range. Okay. Okay, so the collection range computes the slot range during which collection is allowed. So the time interval which collection is allowed. So let's do that. Okay, so we got collection range, campaign, interval, end date, campaign, collection deadline. Alright, so that's pretty simple. Oops, sorry, oops. So that's pretty simple. The collection deadline, the time at which the money can be collected starts when the campaign ends, from when the campaign ends to when the collection deadline is. So between those two dates, in that time interval, we can collect. The owner can collect. Okay. The next function we'll define is called in collection range. In collection range, which takes a campaign and pending transaction returns pool. As you'd expect, it checks to see whether we can we can collect. So in collection range, campaign transaction equals collection range campaign contains pending transaction range transaction. Okay. So each pending transaction has a time interval which is valid. If that time interval, which is pending, which is this expression, this value here, if that time interval is within the collection range of the campaign, which we calculated here, then of course we are in the collection range. So this will return true. Otherwise, it will return false. Now, the next function we'll need is refund range. The campaign gives us a time interval, and the refund range is interval from after collection deadline. Okay, so basically anytime after the collection deadline of the campaign, we can it can be possible. There is a refund possible. I mean, we could of course write this in a pointed fashion like this. Collection deadline campaign. Yeah, perhaps this is a bit more conspicuous. But it just creates basically any time from the collection deadline of the campaign, it is possible for a refund. A refund is possible. Okay. Now, and then of course, we have in refund range, which takes the campaign, as you would expect, a pending transaction, and returns a goal. And then in refund range campaign transaction the refund range campaign contains pending transaction valid range transaction. Okay, so that's that. Now we need to define another helper function. One more, and this we're going to call total input, which takes a pending transaction and returns data. Now, in order to check whether the funding target has been reached, we must calculate the total amount of ADA contained in all inputs of a pending transaction that belong to our script. So that's what total input is supposed to do. So here we go. Total input transaction equals, and then it's just a left fold L F0 pending transaction inputs tx. Okay, so where f takes data pending transaction, pending transaction input, and then ADA. So this is the body of our fold. Okay, and what is going to check? F ADA I from script I equals ADA plus from value pending transaction value I. Okay, so let's just, I mean, it's straightforward, but what we're doing is we get all the transaction inputs from the transaction. Okay, so we're going to give that as a list. And what we do is we fold to the list. So that means since the left fold, we're going to start with the ADA that we've calculated will be on the left, that we've accumulated on the left, and the next element of the list, i.e. the pending transaction input, will be on the right. And what we do is we check if the transaction input is from the script, then we just add ADA, our accumulated ADA up to this point, we add it to the value in the script, to the value of the input. However, if it's not from a script, otherwise, then we don't add anything. We just continue through. We just we've accumulated thus far. Okay, now what we better do though is define from script. What we mean by from script. Okay. From, I don't think that's the one. From script. Okay, takes a pending transaction input, so transaction input, returns boolean. Now the main question is simple. Does this transaction input correspond to an output of our script. So obviously there could be other scripts, running on the blockchain. We're not interested in those. We're only interested in the one that we've written for this crowdsourcing application. So we do from script I equals case pending transaction witness I of nothing, then we just return false. So that will cause us not to add anything. And if on the other hand we get just h, we get a pair, we're only concerned about the first part of the pair, then we check is the hash. If h equals own hash transaction, so basically, does the hash match the hash of this transaction? If they do match, then it means that this script corresponds to our transaction. It's the crowdsourcing script. Otherwise, it's not. So we just basically check to see if the two are true. In fact, let's put a little comment here. The function on hash, which takes pending transaction and returns the validated hash, gives us the hash of the validator script. We are currently evaluating. Okay, and I'm going to take a break here. So that's the end of the first part, and I'll see you again for the second part of our crowdsourcing blockchain. Until then, take care.